15 minutes plus 5 minutes for questions. You can start from here.
Good afternoon, dear colleagues and dear researchers. My name is, as Mr. Bardis mentioned, Savas Kostouras, and I'm a postgraduate student at the Hellenic Military Academy, and specifically in the Department of Mathematics and Engineering Sciences. Before I start, I would like to say great thanks to Professor Bardis for his guidance and extensive knowledge in this scientific area. Now, first of all, the term secure communication constitutes as one of the most important factors of today's communication and communication in general as an entity. Now, at today's communication, where the power and the capabilities of the modern computers are continuously rising, the encryption systems must keep up with this flow in order to ensure the confidentiality and the integrity of the trusted data. Now, the main contributions of this paper in the field of secure and encrypted communication are first the creation and the development of an integrated message exchange system, and second, a detailed and thorough study of the time requirements of key generation, completion of encryption and decryption processes was carried out. Now, let's proceed to the system architecture. First of all, the system that was developed is named as SK-Text and comprises for a server construction for communication support. A database was created for persistent data storage. And lastly, a mobile native application which handles all the rest. Moving on, in this slide are presented the most important aspects of the SK-Text system. First, a key fact of the system is that the native mobile application handles all the encryption and decryption of the data and not the server-side system. Second, this feature ensures that transferred data are already encrypted before the transmission to the destination, and as a result, it reinforces the total integrity of the data. Second, the generation of all encryption keys, which are the secret symmetric key and the public and private asymmetric keys, and their exchange is done exclusively by the users and not by intermediate servers or any cryptographic systems. Now, let's analyze one of the most important aspects of SK-Text system, which is the generation of symmetric conversation key. Now, first of all, when the user is entering into the application of the SK-Text system, its private key is retrieved from the SQLite database and is getting decrypted. Now, the second step consists To commence a new conversation between two users, a symmetric key must be established. First of all, after the typing of the raw key data by the user, the input is hashed by HMAC SHA-256 algorithm with proper use of salt for a more robust hash signature. After the encryption of the data, or after the completion of this action, the hash signature of the key is encrypted with the SHA-256 algorithm, and then the output of the encryption is used as an input to the RSA 2048 bits algorithm to produce the final data for transmission to the recipient. Lastly, the symmetric key is getting transmitted and stored to the SQLite of the device of the user for later usage. Now, we have seen the one end of the creation of a new conversation. Let's see the other end, which of course is the verification of the symmetric key. When the user now is entering into the application, by login or by register. The private asymmetric key is getting retrieved from the SQLite database of the device and is getting decrypted. Now, the second step is the RSA 2048 bits decryption of the received data using the private key that's just being retrieved. The third step is the IS-256 decryption of the output of the previous step. And finally, the data are being stored in SQLite as encrypted from IS-256 algorithm. Now, two actions differ from the generation of the symmetric key. The first action is to delete the special message that was carried from the database for safety reasons. Second, the recipient updates the conversation as now verified and ready to send and receive any messages from the transmitter and the recipient. Now, as previously mentioned, after the symmetric key of the new conversation is set, the transmitter and the recipient can exchange messages. Now, the transmitter can transmit any type of data, any selected files from the native mobile system, any camera pictures, or the current user location. As a second step, of course, the encryption by IS-256 algorithm with the already established symmetric conversation key takes place in order to send the transmitted data to the recipient. Now, regarding the recipient, in order to receive any unread data, a periodic check every 3 seconds for arrival of any unread messages takes place. With the existence of unread messages, the IS-256 algorithm decrypts the data with already established symmetric conversation key. Now, a key factor of the entire system is, of course, the change of the symmetric conversation key. Now, in order to achieve this functionality, the SKTech system provides the ability to the users to change the symmetric key of any conversation at any given time. Although this action of changing the symmetric key is a computationally demanding and complicated one due to the immense internal actions that have to take place. Now, in further details, the sequence of actions is initiated with update of the current conversation status as not verified. Now, an important aspect of changing the symmetric key is the preservation of the history of the conversation messages. Now, the supported options for history preservation are the following: all the messages, last 50 messages, last 20 messages, and of course, none message. Then the user who initiates the change of the symmetric key receives and decrypts all the messages that fall under the selected choice of history preservation with IS-256 algorithm using the old symmetric key. The next step is the encryption of all the above messages with the new symmetric conversation key. Now, as soon as this action is completed, then the user uploads all the new encrypted messages in the database as already read for this conversation. Now, upon completion, all the previous messages of the conversation that were encrypted with the old symmetric key are getting deleted from the conversation. Finally, the new symmetric key of the conversation is getting encrypted and transmitted to the recipient. Now, as previously mentioned, in conjunction to the development of the system, a detailed and in-depth study of the time requirements of messaging, key generation, and encryption and decryption processes was carried out. Now, in this slide, we can observe a glimpse of the tests that were carried out as part of the total experimentation. The tables present test results regarding the processes of symmetric key encryption and decryption amongst the two supported algorithms, which of course are the IEEE and the RSA 2048 bits. Now let's continue specifically for IEEE. The test results are presented regarding the purpose-built implementation of the S2.4 algorithm, and specifically the encryption and decryption processes of the symmetric key data. The S2.4 algorithm requires in the test mobile devices an average value of 0.000248248 seconds to encrypt successfully the 256-bit symmetric chat key. On the other hand, the S2.4 algorithm requires in the test mobile devices an average value of 0.0002772 seconds to successfully decrypt the 256 symmetric chat key. Now, of course, let's refer to the RSA 2048-bit algorithm. In more detail, the RSA 2048-bit algorithm requires in the test mobile devices an average value of 0.2488079 seconds to successfully encrypt the 256-bit encrypted chat key. Similarly, to decrypt the 256-bit symmetric key, the RSA 2048-bit requires in the test mobile devices an average value of 0.2492 and 0.77 seconds to decrypt. Lastly, the change of the symmetric key of any conversation was thoroughly examined as part of the total experimentation. Furthermore, as previously stated, the change of the symmetric key is a complicated and computationally demanding action, as an average required time for the total completion was observed to be 11.127 seconds. Specifically, as a maximum required value was noted at 43.612 seconds for a total of 13.0934 megabytes of data. On the other hand, the minimum required time was noted at 2.528 seconds for a total of 320 messages, measuring at 0.003 megabytes of data. Now, keep in mind, key factors in the key change process are encryption and decryption speed of the test mobile device, as well as internet speed for the upload and the download of all the messages. Finally, I would like to close this presentation with the future research regarding the SK-Text system. Now, future research can be dedicated to the development and supporting of secure voice calls or video calls amongst the members of any chat group. Now, besides the above, an interesting aspect are the group chats. Now, this feature presents challenges for research with emphasis given on the symmetric key generation, distribution, and verification. Thank you very much for your attention. I would now gladly answer any questions that you might have.
Thank you, Mr. Kostoudas. Very nice presentation for your systems that you developed. Have any questions, please? From online? I have questions.
Sure.
We know systems and we use systems like Viber, WhatsApp, Telegram, and so on.
Mm-hmm.
So in these systems, of course, we have to see what's the difference of the process, the time processing that they're using.
All right.
Not depends only from the mobile telephones and the device that you make, but also from the point of the server. So we're going to understand the time processing from that special service that they have, these firms, and the server that you make your experiments, what's the difference? And if somebody will use the system, they need a special server, first of all, or a used service that we use every day. This is the first one question. The second one question is also the systems that we know, they make end-to-end cryptography.
Right.
So it's secure, all secure. And as we saw, you use also the prototype of AS 256 and RSA, and the same they do.
Yes, I
So
understand.
what's the difference between your systems and this system that already were using?
Yes, to answer the first question, in this system, the server is only capable of data transmitting. It does not implement any encryption and decryption of the data. All the encryption, as previously mentioned, is getting done in the native mobile device of the user. So all depends from the user's native mobile device, which implements all the encryption and decryption of the exchange data. The server is only support the communication of the two parties, let's say. Now, as far from for the second question, the main key is that the mobile device is capable of handling the user's input for the generation of the keys. So the difference between SK text and the applications that were widely in as a product is that the user can himself handles all the creation of the keys, such as the symmetric chat key, can change it at every given time of any conversation, and of course the creation of the asymmetric keys for RSA encryption. These two elements, as to my knowledge, in products such as Viber or WhatsApp, as mentioned, they're not in the hand of the user, but in the hands of the backend implementation.
So the security issues is on hand of the user and not to the system.
Yes.
About the keys.
Yes, of course. Of course.
Okay, thank you. Any more question? Okay, no question. Thank you. Thank you very much. Second presentation is